Hey, good morning, everybody. Welcome to your first Wednesday independent work assignment thing. I don't know what to call these. So the plan is you're going to need your workbook here. This we're going to do the notes for lesson 2. We're going to sort of do things backwards, right? The other day in class, we did lesson 1 together online, and then we wrote the lesson 1 notes together. And instead this time, I'm going to ask you to follow along with me in this video and copy the lesson 2 notes, which are on page 5 of the book, which will kind of give you the whole major idea or point behind lesson 2. And then we'll go and explore that together in class tomorrow and the next day. So we're just doing an opposite order, right? Notes and then the activity. So go and grab your book, and then after you write the notes, I'm going to ask you to practice some skills on IXL. You should see the links to the skills on this assignment, like below where you click to see this video. And I'll also show you where to find that stuff and give you some examples of how to do the questions, so you know what you're doing. After you copy these notes, you have to do 3 IXL skills. The links to those 3 skills are below this link that you clicked on Google Classroom. And you have to get at least a score of 80 on each of those skills, because that's what IXL considers like mastering a skill or whatever. So once that score over there on the side of the screen says 80, you can stop for that particular skill, but you got to do all 3. All right. There's 6th grade review skills, because we haven't really done much 7th grade math yet, so I didn't really feel like I should give you 7th grade stuff yet. Let's get our skills back from 6th grade was kind of what I was thinking. All right, so I'm going to share my .cam screen with you. Let's see here. There we go. And so I've got my workbook up here. I'm on page 5. It says unit 7.1. That's the chapter unit we're in Desmos. And then lesson 2, scaling robots. And so the whole point of this lesson is to talk about this really important number that we call the scale factor. If we can figure out what a scale factor is, get used to finding it, get used to calculating it, then we'll be in good shape. So the scale factor, it says to draw an example. Let's write in words first, and then we'll draw an example. And I'm going to kind of use some of this area here that says my notes, just because I have a feeling like the words and the drawing together might take up more space than this allows. So I'm going to start writing over here. The scale factor is the number. All right, so that's already important, right? So now we know one thing. Scale factor is a number. Scale factor is a number by which, kind of a weird way of wording things, but it's like the proper way. The number by which all side lengths of the original drawing, sorry, my L kind of blended in with the line on the paper there. The original drawing are multiplied. Okay, so that's another big, important piece of this. The scale factor is a number that you're always multiplying by. I guess sometimes we might do some things in reverse and do some division to find a scale factor, but when you're using the scale factor, the way you should think of the scale factor is it's a number that's multiplying an original to make a scale drawing. So the number by which all side lengths of the original drawing are multiplied in order to create a, the curriculum, Desmos likes to say scaled copy a lot. I also like to say scale drawing. Those mean kind of the same thing. To create a scale drawing. Okay, so let's see an example of that. I'm going to draw a super simple drawing over here. It's just going to be a rectangle. Let me switch colors up a little bit. Let's go with some purple. I'll make it like kind of wide and short. Okay, and I'm going to call this one the original. and then I'll make one that's like to scale to it. So maybe, I don't have a whole lot of room, so I can't really make it like 3 times bigger. Like maybe I could do 3 times bigger. Oh, but then I don't have room to do my math, so I don't want to make it too messy. So let's just make it an easy example. Let's do twice as big. So I'll try to draw it approximately twice as tall. It's about right. And approximately twice as wide. This is still going to take up more space than I would really like. Notice I made the height like twice as big and the length twice as big, but at the end it doesn't really look twice as big. It looks more like 4 times as big, right? Like you could take 4 of these purple ones and fit them in the orange one. There's a mathematical reason for that. Maybe think about it. I'm not going to talk about it right now. So let's hear it. Let's label the sides different colors. So we'll label this side here with orange, and maybe we'll call this a 5. And so the corresponding side, that means like in the other drawing, the side that is like the same side is this one. We call those corresponding sides. We'll call this a 10 over here, right? And then this one here on the bottom, I don't know, maybe we call it a 15. And so its corresponding side, the one down here on the bottom of the other shape, well, if this one's supposed to be double, then I guess this would have to be 30, right? And we could do the top and the other side as well, but if you know your rectangles, you know that this top one has to be the same as the bottom one here, and this top has to be the same as this bottom, et cetera, right? Like with rectangle, we only really need one side and either the bottom or the top. So let's look at the orange sides here, right? The 5 and the 10, those are corresponding sides. Well, oh, and also I should label this one. I labeled this one as original, so I'll label this one as, I'll label it as scale. That's a little sketchy. We'll talk about that some other time, but for right now, I'll just label it scale drawing. Let's see where we're on the right. How about right here across, scale, copy. All right, and so since these are in orange, I'll write this in orange over here. 5 times blank equals 10. And then these ones are in green, so I'll write this in green. 15 times blank equals 30. Well, I think we can figure out that we need a 2 here in this blank, right? And we need a 2 here in this blank. And so because we were able to take the sides of the original and multiply them by the same number and get the sides of the scale copy, that means that this number here that we multiply by, that's got to be the scale factor. But that only works because the drawing was made right. If we made one of the sides too short and then we weren't able to multiply by 2 on all the sides and there's no scale factor and it gets a little weird, and we'll talk about that more in class. But this is a real basic, easy example. And so I'm going to draw an arrow here and I'm going to say scale factor. So this number 2. 2 in this case is a scale factor because you can take the sides of this rectangle, multiply them by 2 and get the sides of this rectangle. And so they got some examples for us to fill in real quick down here. Let me try zooming in and see if we can get this a little bit better. Wonder if I can focus a little bit too. There we go, that looks good. All right, so it says that these are supposed to be robots. I don't know, they just look like triangles to me. And so they want us to fill in the values in the scale drawing based on what we see in the original. The top one's always the original. And then the bottom one is the scale one. So this triangle here says 5, 8, and 2 are its side lengths, right? And well, here we have 5, 20, and blank. So we got to figure out what number is multiplying by the sides of the small triangle here to get the bigger triangle. So let's see here. 2 times blank equals 5, right? Because these are corresponding sides. 2 times something has to equal this 5 here. And then, so I'll kind of like circle those in green. So you see that those are the ones I mean with the green. And then the orange will be the 8 and the 20 here. So 8 times something equals 20. And then the last one we got to do is purple, but we only have a little bit of information there. 5 times blank equals blank. And that's the part that we're really trying to figure out. Well, if we were in class, I'd give you more time to figure this out. This would be more your job, but you're just copying me right now. I can see that if I multiply 2 times 2.5 or 2.5, I'll get 5. So I'm going to put a 2.5 there. And if I multiply 8 by 2.5, I get 20. So I'm going to put a 2.5 there. And so that means in order for this drawing situation to be to scale or proportional or be a scaled copy, all these things kind of mean the same thing, then I have to multiply by 2.5 here. And so I got to figure out what that is. What's 5 times 2.5? Well, you're just copying right now. I'm going to give you some answers. It's 12.5. And so we put a 12.5 right here on the triangle. That means that this side right here must be 12.5 based on what we know about scale copies and stuff. All right, let's do another one. So in the green over here, we have corresponding sides, 5 and 15. So let's see, I'm going to use this space down here. I'm going to draw an arrow here, and I'm going to go 5 times something has to give me that 15. Okay, well, that's pretty easy. I can fill in that blank, right? 3. So now I know the scale factor between these two triangles or robots, whatever, is 3, meaning everything on the small one needs to get multiplied by 3 in order to make the corresponding sides down here. So this isn't too bad. I see an 8 here, right, on the bottom. Okay, so 8 times 3 gets me 24. So the bottom side length down here has to be a 24. And then I see a 2 up here. That one's really easy. 2 times 3 equals 6. So that means that this right here has to be a 6. All right, and now this last one, well, they didn't really give us any information about the top one. So we can kind of make that however we want, as long as it works, as long as it's to scale. Well, I see that all of the numbers in the bottom triangle are multiples of 5. So I bet we can make our life easier by making the triangle up here have something to do with 5s maybe. What if, oh, and you know, and another thing I see is that this side length here is 4 times bigger than this one, and this one here is 3 times bigger, right? 15 is 3 times bigger than 5, 20 is 4 times bigger than 5. So I think we have to keep those ratios like the same in order for the triangle up here to work. I'm going to make my life as easy as possible. I'm going to make the smallest side up here 1. And so since 15 is 3 times bigger than 5, well then this side here needs to be 3 times bigger than 1. Well, what's 3 times bigger than 1? 3, Mr. Thomas. Okay. And then because 20 is 4 times bigger than 5, this bottom side of this triangle needs to be 4 times bigger than this 1. No? Okay, so that means it's going to have to be a 4, right? So we'll put a 4 there. That one was a little bit weirder, but it just required a little bit of thinking about ratios and proportions. So our scale factor on this one turned out to be 2.5. Our scale factor on this one turned out to be 3. And we kind of created the scale factor on this one. It turns out it's 5, right? Because 1 times 5, we get this 5 here. 3 times 5, we get us this 15. And 4 times 5 would get us this 20. So scale factor on this one's 5. I don't think we need to really write anything in the summary in this situation. Like the info we really need is like here, right? So I think we're good. Let's move on. So the other thing you're supposed to do, let me stop screen sharing real quick. The other thing you're supposed to do is go to IXL and practice those 3 skills. So now I'm going to screen share again this time so you can see my IXL. Let's see here. I am on the IXL login screen that you want to be on. Don't go to just IXL.com. We have our own special sign-in page for BUSD. It's right up here. You can see it, IXL.com/ you don't really need the www and the HTTPS or whatever. Don't worry about that. Just type IXL.com/sign-in/Berkeley. And then you'll get to this page, and then you can just sign in with Google. Make your life way easier. All right, so I'm signing in, clicking my name, and then it's going to take me to the whole IXL dashboard, which hopefully you guys are relatively familiar with, you can just click the links on Google Classroom. It'll take you right to the 3 skills that I want you to practice. But another way you could do it is click on Learning and then go to Math. We're already in Math. And then go to 6th grade, because I assigned you some 6th grade skills. 6th grade. And then all the skills I asked you to practice are ratio stuff. So I'm going to scroll down until I see ratios. And it's these ones, right? Write a ratio word problems, and identify equivalent ratios. And I feel like write a ratio and write a ratio from word problems is relatively easy. I mean, some of you guys might have a hard time with it. I don't know where your skills are really at right now. The toughest one is identify equivalent ratios. So I figured I'd do an example for you on that before I stop this video. So let's see here. A bit. Is it going to give me a question? There we go. So it's asking me, are the ratios 7 to 14 and 1 to 2 equivalent? So let's see here. I'm going to write on the screen here. I like to write my ratios as fractions. There's multiple different ways to write ratios, but for me, I want to think of 7 to 14 as, why isn't this working? It's coming up saying something that my pen, I'm trying to use my pen, it's not working. Hold on, give me a second. Wow. All right, I'm gonna try that one more time. That was weird. If it doesn't work this time, then we'll figure something else out. I'm gonna try to write with my pen. Okay, it really does not want to let me write with my pen right now, which I've never seen this before. So, to the mouse we go. This is gonna look really bad. I'm gonna make the fraction 7/14, right? That's the same as 7:14. And I'm trying to figure out, is that the same thing as 1/2? Well, 2 fractions are equivalent if you can multiply one fraction by 1 and get the other fraction. Okay, well, when I say multiply by 1, another way sometimes math teachers say is they say multiply by the same number on top and bottom. Like if we were to multiply the top here by 2, that's a 2, sorry, it's such an ugly 2, and multiply this by 2, we'd have the fraction, what, 14/28. That doesn't really help us right now though. But that's what I mean when I say multiply by 1. Because really what I did there is I did the same thing on top and bottom, but really I multiplied by 2/2, right? A 2 on top and a 2 on bottom, and 2/2 is the same thing as 1. Well, you're allowed to do it with multiplication and division. If you can divide the top and the bottom of a fraction by the same number and get to the other fraction that you're trying to get, then that means those fractions are equivalent as well. So let's try it again. Let's start with 7/14 again. And I'm going to divide the top. Divide, it's an ugly division symbol. Divide the top by 7. But then if I divide the top by 7, I have to divide the bottom by 7 as well. I got to do the same thing on top and bottom. That way I'm not changing the value of the fraction, right? It's staying the same. And so when I divide the top by 7, well, that's easy. 7 divided by 7 is 1. And when I divide the bottom by 7, 14 divided by 7 is 2. I get 1/2, or 1/2. That's the same thing as this 1:2. And so because I was able to take one fraction, turn it into the other fraction using the same number on top and bottom, either dividing or multiplying, then that means those fractions must be equivalent. They're just different ways of expressing the same number, so we're good. We click yes. Let me get out of this tool. We click yes, they are the same. Oh, I didn't actually click yes. Yes, submit. Yeah, I'm brilliant. All right, so do those 3 IXL skills until you got a score of 80 over here on the side, and I'm gonna go figure out why Zoom won't let me use my little drawing pen tablet thing. That way it works next time we see each other. All right, see you guys tomorrow.